Consider an experiment where 50 milliliters of a 1 molar sodium hydroxide solution that was at 25 degrees Celsius was combined with 50 mils of a 1 molar hydrochloric acid solution, which was also at 25 degrees Celsius. Together, the sodium hydroxide and the hydrochloric acid, a strong base and a strong acid, will neutralize each other and create a salt. During that reaction, heat is released by that reaction to the surrounding water and calorimeter. So afterwards, there is some salt present, and now that solution has a higher temperature, 31.5 degrees Celsius. Given that, and that the heat capacity of the calorimeter is 11.0 joules per degree Celsius, find the enthalpy change for that neutralization reaction. Recall that from the last page that the enthalpy change of a reaction is equal to the heat of the reaction divided by the moles of reactant or product, either one which has a coefficient of 1. You can solve for this by knowing the heat of the reaction. You want to know how much heat was released by the reaction. You can know that by knowing how much heat was absorbed by the water and absorbed by the calorimeter. The heat of the reaction is equal to the heat of the solution plus calorimeter all times -1, because the reaction might have released heat and the solution and calorimeter might have absorbed heat, so having opposite things there, they'll have opposite signs. You have this equation, and now you can start plugging in. The heat of the solution is equal to the mass of the solution times the specific heat of the solution times the change in temperature of the solution. And the heat of the calorimeter is equal to the heat capacity of the calorimeter times the change in temperature of the calorimeter. So you combine 50 grams of the sodium hydroxide solution and 50 grams of the hydrochloric acid solution, a total mass of 100 grams. And those solutions were not entirely water. They were 95% water or so. So the specific heat of that solution is not exactly 4.184 joules per gram degree Celsius, but it's very close to that. And so anytime that we're dealing with an aqueous solution, something that's mostly water, we're going to assume a specific heat of 4.184 joules per gram degree Celsius. And we know the final temperature of the solution was 31.5 degrees Celsius, but both of the original solutions started at 25.0 degrees Celsius, so we can solve for the change in temperature there. It's equal to the final minus initial temperature. And similarly, we have the heat capacity of the calorimeter and the change in temperature of the calorimeter, and all of that ends up giving us a heat of reaction of negative 2,793 joules. To find the enthalpy change of the reaction, divide those number of joules by the number of moles of one of the reactants that had a coefficient of 1, either sodium hydroxide or hydrochloric acid, not both. But yeah, you could choose sodium hydroxide, for example. The number of moles of it is equal to the molarity of it times the liters of it. And so we solve for a certain number of joules per mole, or divided by 1,000 kilojoules per mole, the most common unit for enthalpy change, kilojoules per mole. This is a negative value because it is exothermic. Exothermic reactions release heat and have a negative delta H.